Now let's do some concave mirror diagrams. Remember, when you do any kind of diagram, use a ruler. Very important. I will be freehanding these. I profusely apologize for how messy it's going to be. Now remember, for concave mirrors, the focus is going to be positive. So let me do the little sketch here. So it's going to look like this, where this is my principal axis. And everything always is measured relative to the principal axis. Put in the back of your mirror, because we always measure from the back. We're exaggerating this curve here. You draw in your focus, and then you draw in the center of curvature, which is twice the focus. That's not very accurate, but that's okay. Now remember, there are 3 rays, okay? You're going to go in and then reflect out. So we're just going to call this out. You go in parallel, and it'll bounce out through the focus. Because remember, if I have a concave mirror, if here's my mirror on my principal axis, and here's the back of my mirror, and I have a bunch of parallel rays coming in, all of these parallel rays are going to reflect through the focus. Okay, every one of them is going to come and bounce back off through the focus. All right, so parallel rays go in and bounce out through the focus. The second ray is in through the focus, F-O-C-U-S. All right, so imagine we reverse the ray, it comes off through the focus, it's going to bounce off parallel. And then the last ray is through the center and straight back on itself. Also, remember to draw your arrows to show the direction. If your image is behind the mirror, it will be virtual. If it's in front of the mirror, it will be real, because light rays are really supposed to be on the same side of the mirror as the object. Now let's do a few. All right, here my object distance is greater than 2f. So we're going to put it in the back of the mirror here. All right, it's going to go in parallel, and bounce off through the focus. All right, see, I'm putting my arrows. The next one's going to go in through the focus. Kind of steep here. And it's going to bounce off parallel. And the last one is through the center. Let's see if I can. So I've really messed these up. So my image here, I'm going to go this way. My image for this one is where these 3 cross, which is about right here, and down. Now it's real, because the rays really cross there. It's reduced, and it is inverted. Now let's see if that makes sense. 1 over f is 1 over SO plus 1 over SI. So I'm going to solve this for SI. So 1 over f minus 1 over SO is 1 over SI. I'm going to get a common denominator of f, SO minus F. So your image distance is F, SO divided by SO minus F. So if my object is further than my focus, indeed, I should have a positive image. Now, in this case, my object is sitting on the radius of curvature. So my first ray is going to be in parallel. I forgot to put it in the back of my mirror. Put it in the back of your mirror. In parallel, and this is going to bounce off through the focus. I didn't do a very good job with that one, but that's okay. Second one is in through the focus, so you line up the top, go through the focus, and then you're going to bounce off parallel. Now, the one through the center you can't really do, can you? Because to go from the center through the tip, you're going to wind up going straight up and down. But aha, look what happened. Turns out you can do that one. The rays intersect right here. And it turns out you have a real image that's inverted, and your magnification is equal to 1. Now here, we're between the focus and the center. Let me go and put in the back of my mirror before I forget. First ray is in parallel. That's not real parallel, I know. You'll do better. I missed that. Let me just start that one over. Start over. Sometimes, yeah, just need a fresh copy, don't you? All right, in parallel. I'm just going to bounce off through the focus. Second ray is in through the focus. Now my focus is kind of big, so y'all need to be a little patient with me here. And then my third ray, it's between here and here. So, well, let me change colors here. All right, it's between here and here. All right, so we're going to extend this line on down. And if you draw your lines straight, which mine are not, you see it would be right here. All right, so you have an inverted, real, does that look enlarged to you? It looks enlarged to me, image. Now what if we're sitting on the focus? I love this problem. It's kind of fun. Here's my center. Here's my focus. First ray is in parallel. Then it's going to bounce off through the focus. All right, if we do in through the focus out parallel, we have a vertical line. Okay. Now let's see what happens when we go in through the center. All right. These three rays do not intersect anywhere. As a matter of fact, these two are parallel. So there is no image. All right. Now what do you do when you're inside the focus? For this one, put in the back of your mirror. Oh, back of a mirror had issues. Rid of that part. Okay, this one's kind of fun too. In parallel, it's going to bounce off through the focus. Let me do that again. In parallel, out parallel. Now in through the focus. So you're going to have to do this right here. You know what? I did not get my mirror up nearly tall enough, did I? Pretend like a straight line. So in through the focus, it's going to reflect off parallel. And then straight through the center. All right, see these three rays do not intersect. So we need to dot back our reflected ray. So the one with the arrow gets reflected back. I didn't get that color right, but that's okay. So now I have a virtual, upright, enlarged image.